Okay, for today in Algebra 2, we have absolute value inequalities, so section 1.9. Our objectives are to write, write an absolute value inequality as a compound inequality, solve and graph absolute value inequalities, and to write absolute value inequalities describing graphs and real-life situations. So several things to do there. All right, so let's look first at this first part. It says, while the equation, the absolute value of x equals 3, can be interpreted as x is 3 units from 0 on the number line. We've always kind of talked about that. The inequality, the absolute value of x, is greater than 3, describes all the numbers more than 3 units from the origin. Okay, it's describing all the numbers more than 3. And the absolute value of x is is less than 3 describes all the numbers less than 3 units from the origin. So this is the first time we've had the variable inside of our absolute value in Algebra 2. It's kind of the first time we've done that. We didn't really discuss these much in Algebra 1. Okay, but let's look at this graph. So when we're graphing this, the absolute value of x is greater than 3. Okay, we are getting all of the numbers, right? All the numbers that are more than 3 units from the origin. So it's not 3, so we have that open circle, and it's going to the right for the positive side. And it's not negative 3, but it is going on and continuing to the left into the negatives. Because this, the absolute value of x is greater than 3, is actually equivalent to x is greater than 3 or x is less than negative 3. Okay, so it's going either one. So this is a disjunction, right? It's an or statement. The next one, the absolute value of x is less than 3, is saying that it's equivalent to negative 3 is less than x, but x is also less than 3. So again, we have our open circles, and x is the distance in between those. Okay, that right there is the conjunction. It's an and statement. Okay, it's the conjunction because it's an and statement. All right, so the solution to an absolute value inequality can be written as a compound inequality. That's what we're trying to get to and figure out today, is how do we write these. I will tell you that when you have a greater than, x is greater than, you're always going to have an or statement. And when you have x's, or when it's less than, your absolute value is less than, it's always going to be a conjunction or an and statement. Okay, that is very helpful. All right, so let me clear this and we'll get started on some examples. All right, so example 1 says solve the square or the absolute value of x is greater than or equal to 2 and graph the solution set. All right, so it's a greater than, first of all, greater than or equal to, but the fact that it's greater than is going to make it an or statement. Okay, it's going to be an or statement because we know x is greater than or equal to 2 or x is less than or equal to negative 2. And the way that we can know this is also if we say, really, let me back up a step so you could understand this. I kind of skipped a step. Oh, sorry. Try to get my eraser and it didn't show up. You guys know how that goes. Okay, so we can say x is greater than 2 or negative x is greater than or equal to 2. Okay, so this is our or statement that we're putting in there. Well, if we divide by a negative 1, that means we have to flip our sign. So then we would have x is less than or equal to negative 2. as well as x is greater than or equal to 2. So that's how come we flip our sign, okay, or how we end up with it's less than -2. We're not just picking. We're saying if x is positive versus if x is negative, what we're going to get. All right, so now we have to graph this. It is greater than or equal to 2, so we're going to have a closed circle. Okay, so we're going to have a closed circle at 2, and it going to the right. This is the side that is x is greater than or equal to 2. Then our next one, x is less than or equal to -2. So again, it's a closed circle, and it's less than, so we're going to the left. This is the x is less than or equal to -2, and we're going to have or in the middle. All right, on example 2, maybe should have had a little bit more room here to solve, but we have the absolute value of 2x minus 7 is less than 4. Okay, so same thing. We can take 2x minus 7 and say it's less than 4, or we're going to have a negative of the quantity 2x plus 7. Oh, I wrote it wrong. Plus 7 over here is less than 4. Okay, so either we're going to solve both of these and see what comes of it. All right, so we subtract 7. 2x is less than -3. Divide by 2. And we have x is less than -3 halves. I think I have a typo in my... Oh, from your notes to my notes, I have a typo. So one of the places I made a mistake. That's okay. All right, then this one, we could go ahead and we can distribute, or we could divide. So let's distribute actually. So I'll have -2x minus 7 is less than 4. Okay, so we're going to add 7 to both sides. So we have -2x is less than 11. We're going to divide by -2. And then we're going to get x is greater than, pardon me, got to flip. X is greater than -11 halves. Okay, so x is less than -3 halves. Okay, so let's put some numbers on our graph here because I don't have any. So let's see, 3 halves, -3 halves, -11 halves. Okay, so let's have 0 here. And then we could do 1, -1, -2, -3. That's not going to work, is it? Because we need -11 halves, which would be 5.5. So that won't work quite right. Okay, we could still have 0 over here. We'll just have -1, -2, -3, -4, -5, -6, -7. That should cover us. Okay, so -3 halves. All right, so let's grab this. X is less than -3 halves. So -3 halves is -1.5. It's less than, so we're going to have an open circle. And it's less than, so we're going to the left. And x is greater than -11 halves. So -11 halves would be, I'm going to change my color, -5.5. Okay, so that'll be right here. And it's saying x is greater than. Well, wait a minute, that's going this way, right? So this is that conjunction. We can, because it's bound by each other. Okay, so our final answer here is we have to stop at each of those open circles. Okay, it's only the solution that's in between here that are solutions. So we would say, okay, it's a little hard to think about these if you put x in the middle. So x is less than negative 3/2. Okay, so we have x is less than negative 3/2. Okay, but x is also greater than negative 11/2, which means if we rewrote this, so where x was in the middle, sometimes that's what we have to do. So we have to write negative 11/2, flip the sign to rewrite it, okay, is greater than x. That way it can be like, oh, this needs to come over here where we're going to have this part to see that they connect. Okay, so we know a negative 11/2 is less than x. X is less than negative 3/2. So sometimes you have to reorder them so that you can see how they connect and how you would write their final one. Okay, let's move on. Then we have the absolute inequality theorem. Okay, and it states that if c is greater than or equal to 0, then the absolute value of c is less than, or the absolute value of x is less than c, is equivalent to the conjunction negative c is less than x is less than c. That's example 2. And if the absolute value of x is greater than c, that is equivalent to the disjunction x is less than negative c or x is greater than c. That's going to be example 3 that we do. Okay, so we've kind of already talked about this at the beginning when I talked about a conjunction and which one's a disjunction. Okay, same things. But you must isolate, here's the thing, you must isolate the absolute values to solve the inequality. You have to get them by themselves. This example 3 is the first problem we've had where we need to do this. So it's one of those you need to remember as well. All right, so example 3, we're going to solve the absolute value of the quantity negative 4x plus 9, subtract 11, and that's greater than or equal to 4. So here's our problem. Our absolute value is not isolated. We have minus 11. So first we need to add 11 to both sides. That would give us the absolute value of negative 4x plus 9 is greater than or equal to 15. All right, so now our absolute value sign is isolated. This is a greater than or equal to, so it's going to be a disjunction. We should be able to determine that already. All right, so what this means is we're going to have, well, negative 4x plus 9 is greater than or equal to 15, or we're going to have a negative that quantity. Negative 4x plus 9 is greater than or equal to 15. Okay, so let's solve this first one. We would subtract 9. We would have negative 4x is greater than or equal to 15 minus 9, which is 6. We would divide by negative 4, which means we flip our sign, and we would have x equals negative 6/4, which is, or we would reduce that to negative 3/2. All right, next one. Last time we distributed first. This time we could divide by the negative and see what happens, right? It might create extra work for us, but you'll see you can do it either way. So if we divide by the negative 1 out here, then just those first negatives cancel. So we still end up with a negative 4x plus 9, not 19, plus 9 is, we have to flip our sign, less than or equal to negative 15. Okay, then we subtract 9. Negative 4x is less than or equal to negative 15 minus 9 is negative 24. Divide by negative 4, and we get x, and we have to flip our sign again, is greater than or equal to a positive 6. All right, so it did create extra work by not distributing, because then we had to flip the sign twice. So it truly is up to you, but you need to make that decision each time which one to do. All right, so then let's go back and graph this. Okay, so we have on our graph, let's see, we need to go up to 6 and negative 1.5. So let's do -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. All right, so x is less than or equal to -3/2. So we're going to have a solid circle at -1.5. And we know x is less than, so we're going to the left. All right, then we have x is greater than or equal to 6. So we're going to have a solid circle. And it's going to the right because it's greater than. So this is that disjunction. Okay, so we would write both of those. X is less than or equal to -3/2, or x is greater than or equal to 6. Okay, there is our disjunction for that. Awesome work. Okay, let's clear that. Okay, example 4. We want to solve and graph the solution sets. Okay, or each solution set. All right, so we have the absolute value of x is less than -3. Okay, so again, we're going to break this down into x is less than -3 and negative x is less than -3. Well, this one's already done for us. This one we have to divide by -1. X is greater than 3. All right, and looking at this one, is this one a conjunction or a disjunction? Okay, it's a conjunction because it's less than. A conjunction because it's less than. So that's always helpful to remember. But again, when you graph it, you should be able to tell that. So we've got 0, 1, 2, 3, 4, -1, -2, -3, -4. All right, so x is less than -3, open circle, less than, x is greater than +3, open circle, to the right. So x is less than -3 or x is greater than 3 because it's a conjunction. All right, B, we have a greater than sign, so we know that it should be a disjunction if we're thinking about it. So we have x is greater than -3 or negative x is greater than -3. Divide by -1, flip our sign. So we have x is less than 3 and x is greater than -3. So again, if we graph it, it's going to prove if it's a conjunction or a disjunction. So x is greater than -3. We're headed this way. X is less than 3. We're headed to the left. So it's the area of overlap. Okay, so we would say x is less than 3. And then we could flip this one to say, all right, but -3 is less than x to get that disjunction in there. And now that I think about this, at the beginning of the notes, I might have written those backwards, the conjunction and the disjunction for less than and greater than. So if I did, I am terribly sorry before we got to the part that actually said that. So please fix your notes and please forgive me. All right, since the absolute value of any number is positive or 0, inequalities such as the absolute value of x is less than -3, see this negative? They have no solution, okay? No solution. And the solution to inequalities like the absolute value of x is greater than -3 is the set of all real numbers. Okay, so if it is greater than -3, then it is the set of all real numbers is the solution. Okay, so Let's look at example 5. It says write an absolute value inequality representing the graph. All right, so the first thing we need to do is to find the midpoint. Okay, and then the second thing, we're going to find the distance between an endpoint and the midpoint. Because to write this absolute value equality, it really is going to look like the endpoint minus the midpoint inside that absolute value, and that's going to equal d, your distance. Okay, but we need to know the midpoint, and then we need to know the distance. All right, so we have a -5, right, and a +1. So we need to find the midpoint. If you recall, to find the midpoint equation, right, is to take the values and add them and then divide by 2. So -5 plus 1 is 4 over 2. 4 divided by 2 is 2. So our midpoint is -2, pardon me, because -5 plus 1 is -4, so -2. Okay, so then step 2, we need to find, so this is step 1. Step 2, we need to find the distance. So we use the distance formula. Okay, so the distance is the distance between an endpoint, pardon me, and the midpoint. That's important. So we want the between the endpoint and the midpoint distance. Okay, so our midpoint is -2. I'm going to mark it on there as m. All right, so let's take -5. So the distance formula, we're going to subtract those values, right? And we set them, that equals 5 minus -2 is going to equal 3. Okay, so we're using this formula there to find our distance. So 5 minus -2 is a -3. The absolute value of -3 is 3. Maybe I should have put a little bit more work there for you. All right, so now we're ready to write the absolute value inequality representing the graph. Okay. Hopefully you remember this from yesterday, or what we did before. If you recall, that formula for an absolute value inequality is, or equation is what we did yesterday. We're going to change it to an inequality, is x minus m inside our absolute values, okay, equals d. Okay, so here we're going to have x, the absolute value of x, minus our midpoint, which is -2, equals our distance, which is 3. But we need an absolute value, or we need an inequality, not an equation. So which would it be? Would this actually be less than or equal to? Right there. Good. It is less than. How do you know it's less than? Is it a conjunction or a disjunction? Good. It's a conjunction. So it is less than. Excellent, excellent. And you could simplify this as well because you have that minus the negative. So if you want to say it's x, the absolute value of x plus 2 is less than 3, that is also acceptable. We would take that totally. Okay, so either of those. All right, so let's move on up to example 6. Last one. This one's a little bit different. Okay, changing gears. We're talking about tolerance here, and there's a tolerance formula. All right, so a power company assures a manufacturer that its 120 volt service will be regulated to not more than a 5% variation in voltage. Write an absolute value inequality. So see, this is how it relates to what we're doing, representing the regulated voltage. Then solve for the range of the voltage. Okay, so this is pretty crazy. But I gave you a tolerance formula. And so it's going to be the absolute value of the actual minus the ideal is less than or equal to the tolerance. Okay, and we want it to be a less than or equal to because it's a range. Okay, that's going to be in there. So let's look at this. The power company assures the manufacturer that its 120 volt service will be regulated to not more than, so that's that less than, 5% variation in voltage. So it can go either direction. Okay, so if this is the 120, right, it can go 5% above, it could go 5% below, but that is it, right? There are ends on that. So we're looking for that conjunction is what we want. All right, so write the absolute value inequality. So our actual, if we're looking at this formula, our actual number is, we don't know, right? We don't know what it's going to drop to or anything. So that's where we put our X. Minus our ideal voltage. Well, our ideal voltage is the 120. And that is less than or equal to our tolerance. What is our tolerance? Okay, it's 5%. We also have to think it's 5% of this number. So you can go ahead and do that multiplication, right? And do 5% of 120 if you want, which would equal 6. Or you could write the formula here. You could say, okay, well, it's going to be the 5% of 120. You can write it in the equation, or you could say the absolute value of x minus 120 is less than or equal to 6. Either one is perfectly fine. Okay, I would take either of those. Now, it is time then to solve for the range of the voltage. Okay, so the same way we've done this, we're going to split it off into two equations. So the first one is going to be x minus 120 is less than or equal to 6. The other one is going to be negative x minus 120, the quantity, x minus 120 is less than or equal to 6, which would give us negative x plus 120 is less than or equal to 6. All right, so let's solve. We're going to add 120 over here to both sides. So x is less than or equal to 126. Over here, we're going to subtract 120. So we have negative x is less than or equal to negative 114. And then we're going to divide by negative 1, which means we flip our sign. Let me erase that. It kind of looks like a negative, and it shouldn't be. So x is greater than or equal to 114. So x has to be less than 126, and it also has to be, x has to be greater than 114. So we would write that as, pardon the computer there, 114 is less, no, yeah, 114 is less than or equal to x, because x has to be greater than or equal to 114, but x has to be less than or equal to 126. And that would be volts. I should have put a V in there maybe for our volts. Okay, but you shouldn't have too much homework on tolerance. We're going to wait and review that some more when I'm here, and we'll do a worksheet on some tolerance. So have a great night, and I will see you tomorrow.